When people talk about the learning continues, they often jump straight to tools. The better starting point is the mental model. Once the core ideas are clear, the technology choices make a lot more sense. This topic matters because it changes how engineers make design decisions under pressure. Denormalization is critical for systems that prioritize fast reads over data consistency. Horizontal scaling allows systems to grow without single points of failure. If this term is new, here is the simple version. Denormalization is when you store data in a way that makes queries faster, even if it means repeating data. Denormalization helps speed up read operations by reducing the need for joins. Facebook's timeline uses denormalization to quickly display user posts and updates. Here is the concrete picture. Facebook uses horizontal scaling to manage billions of daily active users. That example matters because horizontal scaling is essential for handling large user bases and high traffic. A distributed data store is a system that stores data across multiple machines to improve availability and performance. Distributed data stores are vital for systems that need to scale globally. Distributed data stores help systems handle large data volumes and high availability requirements. If this term is new, here is the simple version. Event-driven architecture is a design where systems respond to events rather than being controlled by a central process. Event-driven systems allow for real-time interactions and asynchronous processing. Facebook Chat uses event-driven architecture to handle real-time messaging. Here is the concrete picture. Facebook uses Memcache to cache user data and improve performance. That example matters because caching is essential for improving performance in high-traffic systems. Consistency vs availability is a trade-off, where systems must choose between ensuring data is always correct or ensuring services are always available. This trade-off is central to designing scalable and fault-tolerant systems. Understanding this trade-off helps design systems that balance reliability and uptime. At this point, the important shift is to stop viewing these concepts in isolation. A distributed data store is a system that stores data across multiple machines to improve availability and performance. Caching is storing copies of frequently accessed data to reduce database load and improve response times. Once those pieces connect, the overall system design starts to make much more sense. A common mistake is optimizing one small part of the system while ignoring the surrounding trade-off. Netflix uses load balancing to manage traffic across its global user base. That is why this topic shows up so often in system design interviews and production incidents. If you remember one thing, make it this. The learning continues is really about choosing the right trade-off for the workload in front of you. Strong system design starts there.